Hello, everybody. Welcome to another episode of The Agent is In. Today, we've got Jason Rogers and Wesley Peck from Invary joining us to talk about some interesting stuff they're doing around finding hidden rootkits. And then I've been playing around with one of these, and so we'll take a look at some of that stuff a little bit later. So kind of want to start off maybe with some introductions. I mean, anybody who's been here probably knows who the rest of us are, but at least Jason and Wesley, can you tell us who you guys are and what your background is?
Sure. Wes, do you want to go first?
Yeah, sure. My name is Wesley Peck. I spent a long time at the University of Kansas doing some secure operating system research under Dr. Perry Alexander. And as part of that, did some FPGA work and some operating system work, and ended up doing a specification refinement technique to lower some of Perry Alexander's Rosetta language down to a TPM that could run in an FPGA. So after I graduated with my doctorate there, I went to work with Jason at Motorola and did some IoT stuff there, and then did some IoT stuff at Lowe's, where we were building really large scale internet scale platforms. Ended up going to a company in Silicon Valley named Matterport, where they designed a 3D camera that would digitize buildings. It's really cool tech. So ended up as director of core platform over there at Matterport, building again large scale internet scale data platforms. Got the opportunity to reconnect with Dr. Alexander and Jason Rogers over this Invary stuff to come back and kind of combine my expertise in large scale internet platforms and secure operating systems and kind of connect those two dots. So it's really interesting stuff.
Awesome.
Thanks, Wes. When Wes and I introduce ourselves, one of us steals the other thunder because we've been together for a long time. So I'm Jason. I'm the CEO of Invary. Prior to that, I ran Matterport's platform group. As Wes said, Matterport is a spatial data company, so they store petabytes of 3D data about real world physical properties, and they use that both to showcase those properties and extract data from where the fire extinguisher is. What's the distance between here and the nearest exit? So it was viewed tens of millions of times a month. So if you go to Zillow, Realtor, those types of places, and you ever do a walkthrough, that's Matterport behind most of those things. So large internet scale platforms, and we opened a government business at Matterport and did several other things there, which were kind of fun. And then before that, as Wes mentioned, we built a consumer-facing IoT platform at Lowe's called Iris by Lowe's, which was fun. Again, internet scale. And so Wes and I have kind of come at the security angle as operators for a long time, both at Motorola and devices and software, all the way through IoT devices and platforms, and then Matterport and high school platforms. But it's nice to connect through the research side of security with Dr. Alexander and Wes's background there into our practical application of it.
Awesome. So what is Invary?
In a nutshell, Invary is zero trust for operating systems. So kind of like you hinted at the beginning, we detect rootkits and other malware that infest the operating system that hides itself from most modern threat detection systems. So there's a good write-up that Dr. Peck did on our website that takes you through how a rootkit called DroverRub works, how it hides itself from modern XDR systems, and then how our runtime integrity technology detects those things. And what we're really trying to do is, no matter what your security solution in the ecosystem, you're only as good as the information that you're being given. And if the operating system is lying to you, it can hide files on disk, processes running, memory, network activity. Then you're operating against their false assumptions. And so we don't think that today a lot of people think about the operating system in a zero trust architecture, but we think we can add integrity to that and appraise operating systems, find this malware, let folks know if their operating systems are okay or not.
So how did you guys develop this? Like, how does it work? How did you come up with this idea?
It's Wes's fault. No, somewhat Wes's fault. So it turns out one of our founders, Dr. Perry Alexander, Wes mentioned earlier, is a researcher and professor, distinguished professor at the University of Kansas. And he's been doing secure computing research for decades now. And he works with the government and DARPA around runtime integrity attestation services. Through that research, a department in the DoD created some technology to do runtime integrity attestation of operating systems for use inside the government. And then they came back to Dr. Alexander and asked him if he wanted to license it and form a company around it. And their mission is to protect us. So if they get this technology out into the commercial world, it protects all of us. Also to kind of help grow the economy and to further the work that they started. So we are actually jump-started from an IP license from the DoD. And then Dr. Alexander came and talked to Wes and I, obviously very familiar with Wes, and we've had the good fortune of working with Dr. Alexander's wife for a couple of decades as well. So we've known him for a bit. So we came together and decided we would apply sort of the research aspect that Wes and Dr. Alexander brought with our practical aspects and start Invary, which wasn't its original name.
All right, what was the original name?
Well, the actual company name is Ad Astra Integrity Measurement, Inc. That's a lot to say. And then we had a different brand name that we don't talk about. And then
all right. So I guess what makes it different?
So I'll start at the high level and then I'll let Wes go into the details. And again, some of you have heard this before, but we like to use the analogy of the night sky. So if I look up at the night sky, I know that the stars have invariance to them. I know what the shape of the Big Dipper is. I know where it's at in the night sky. I know if it changed shape or if it's in a different location, something has gone horribly wrong. But yet the night sky is super complex, right? There are trillions and billions and all kinds of stars and galaxies and things out there, but they have invariance to them. So we look at software kind of the same way. We look at operating systems, their structures and the behavior of their structures when they're operating as intended have an invariance to them. And so we measure a lot of that up front, and then we appraise real-time systems against what we see in a huge graph. And I don't know, Wes, if you want to expand on how it works a bit.
Yeah, I mean, I think the night sky analogy, works pretty well. And it maps almost directly onto what we end up doing inside the software. It's just that the stars in the night sky become data structures in your software, right? Either statically or dynamically allocated data structures. And then those data structures have pointers between them, right? So you connect data structures to other data structures, typically in a software program, using a pointer, or some languages call them references, that sort of thing. But the point is you have one structure embedded inside another structure, and that can take a couple of forms. So one of those forms is a pointer or a reference, right? So those references end up becoming edges in the graph, right? So we have a bunch of logic for the Linux operating system that says, go measure these structures. In these structures, pull out these pointers and make them edges. A bunch of logic that says, here are the roots to start from. Go start your measurement here. And then as you follow those pointers, you're measuring more and more of the object graph as you go, right? So you end up with just ginormous object graph of important structures within the kernel that control how it behaves as it moves into the future. So these data structures are controlling logic in the operating system that says, oh, you should or should not be able to read this file. You should or should not be able to open this network socket, right? You should or should not be able to use this physical device, that sort of thing. And that applies to both the user abstraction, so users on your machine, but also at the application abstraction, where this application can or cannot access these resources, right? So we go out and we measure this huge object graph of data structures that are really critically important to the operating system, enforcing security for your entire system, not just for itself, but for all the applications and all the users running on that system. Then at the end of that flows up to our appraisal platform that we run in the cloud. And we have a bunch of sophisticated appraisal logic that looks at not just the nodes in the graph, but also the edges in the graph. So we're looking at, okay, is this data structure set up correctly? But also, is this data structure pointing to the other data structures that it should be pointing to? And even beyond just first level, right? It's this entire graph. Does this entire graph, subgraph of the overall object graph look correct? And so if it does, it passes appraisal. And if it doesn't, it doesn't pass appraisal. And if it doesn't, we know in a lot of detail exactly why it doesn't. So the kind of error messages that you get out of our integrity product are very specific. They're, I checked this data structure. It is supposed to have a pointer here that points to the syscall read function. And instead of pointing to the syscall read function, it's pointing over here to this other module, to this other address of this thing I don't know about. And that's not.
So, I mean, I was reading this morning about this new hiatus rat or whatever. So it's been around or whatever, but there's this new volume of compromise that are doing it. And this one is like, you know how to look for it, right? So it's like it puts its data in a specific place on your file system. It listens on a specific port. But I mean that's not the kind of like rootkit that your software, I guess, might be able to detect some of that stuff, but it's not, I guess, what you're targeting. I mean, how prevalent are these types of, hidden malware that like don't have this known fingerprint?
I think there's one of the scary things about them. And the good thing about the technology is that anything that alters the kernel, we should be able to detect. And so we talk about novel, 0-day, all the fancy words. But should somebody construct a new exploit to try to hide itself in the kernel, we should be able to detect that on 0-day. The prevalence of rootkits, they're meant to hide an attacker forever at times. We were recently at a cybersecurity conference at KU and got a chance to speak alongside the FBI. The FBI had really good data around the amount of attacks from sophisticated attackers, state actors, or well-organized groups of attackers continue to rise, and also they continue to attack anybody. So you would think, oh, of course they're going to go after government or critical infrastructure, but they'll go after anybody. Sometimes for money, sometimes just to terrorize and make problems for us. And so unfortunately, these types of attacks are very difficult to find, and a lot of systems can't find them, and are on the rise overall. And again, the Drover Rub example was hidden for a long time. And finally, the FBI and the NSA together disclosed it and say, this is out here. It's infecting lots of people, and you all need to be aware of it. And you hear about them every day, almost, it seems like. Samsung had a recent exploit in their phones. Wes, do you want to walk through? Do you remember that one enough to walk through how it worked?
I only remember the very highest level details, but from what I recall, there was a bug in one of the graphics drivers used in the kernel. That bug allowed a root exploit, and through the root exploit, they were able to write into kernel memory. And so they would write a rootkit into the kernel memory in kind of this side-loaded fashion. It's not going through a normal like kernel module or anything like that, right? So they wrote directly into kernel memory some instructions to modify the kernel's behavior, and then modify the right places in the kernel to start executing those functions. And they were able to exfil some data using that approach.
And that's key too. I think, traditional, what you can think of like boot time integrity checking, or even some of the existing runtime integrity stuff that's out there, focuses on sort of hashing of objects. Is this file what it is? And that particular attack and a kernel exploit changed it in memory, and a lot of those hashes are going to pass, which is why, our approach at sort of checking the behavior of the systems and the interaction between these things sort of matters.
So, I mean, you've mentioned, some different organizations and stuff like that. Can you tell us who's using this stuff now? And I guess maybe more interestingly, like, do you have some interesting stories
Well, so in terms of who's using it, so on our side, we've just recently launched our initial free service that allows folks to check the integrity of their operating system once, called Rise. So you can check it out on our website. And then, what I think Nick's going to take us through here in a little bit is sort of preview what our SaaS application will be able to do and integrate with systems like CFEngine. So we're pretty early. We do have health systems using the software. We have large scale SaaS service companies using the software. There's some enterprise software companies. I'll try to stay generic out there using software. There are other entities using this technology that we can't speak a lot about, but it's definitely been in use for a while now on critical infrastructure in places that it's needed. And again, it's our job to kind of get it out to everybody, sort of democratize its access so we can all be safe.
So, I mean, do you have any other ideas for how your software can be applied? I mean, other than basically fingerprinting the kernel? Yeah,
for sure. We kind of think about it in two directions, sort of horizontal and vertical. So right now we only support Linux operating systems. We can talk about the distributions and kernels and how we do that. But we'll move into Windows operating systems here at the end of this year into early next year. We're focused on the server market for Linux for obvious reasons, but also, these companies that have large amounts of aggregated data are often targets of attacks, and they hold a lot of sensitive information for their customers. And so we want to make sure we secure that. But we'll move into mobile PC market. The technology works today, it could work on any Linux system, including an IoT system. But there's some hardening that maybe needs to happen to really deploy it across that ecosystem quickly. And so it will work today, but there may be some bespoke kernels out there that we would need to do some manual work today that we want to get rid of for the future. So bringing it across more and more devices is sort of one approach. And then the other one is we actually think we can take these techniques that look at shapes up the stack to software all the way up to a two-party transaction. So the idea is if I'm going to send $100 to Craig, my machine to his machine, today we have identity worked out. So I'm Jason, he's Craig. We would do that encrypted, and so it's a safe transaction. But what we don't know today is I don't know if Craig's machine is healthy or has integrity, and Craig doesn't know if my machine has integrity. So if Craig's machine's been compromised, I send him $100, it gets stolen, he's mad at me because he doesn't have his $100. That's an issue. So we think we can arbitrate that a system has integrity, and then we can share that information between two parties to kind of make that transaction safer. And then Wes, I don't know if you want to talk a bit about how we move that into the application space and do some of that.
Yeah, I mean, we have a lot of stuff there, like Jason talked about. One of the easier things to talk about that doesn't dive into too much technical details is just protecting very commonly used libraries that ship alongside operating systems, right? So if you think about Linux, your libc comes to mind immediately, right? Almost every application is going through libc to interface with the operating system. So we can attack that library and understand how to measure and protect that library, OpenSSL and other encryption libraries and that sort of thing. But then also getting to the point where we can have a way for customers to describe how their systems should be measured. Right. So this is getting into kind of like CFEngine has a language for describing how to configure any system. Right. So like, I don't care what your system is. I don't care if it's Windows. I don't care if it's HP. I don't care if it's Linux. You use this language, you deploy it, everything works. Right. I think we can get to the point where we have a language of some sort where we allow a customer to describe, these are the important invariants I want to hold within my software. And I want you to go measure those invariants and appraise them and make sure that they're actually holding. So there's lots of steps there where some of it's at the beginning more on us to go protect these commonly shared libraries. And then we kind of push more and more to the point where customers are able to do it themselves as well.
Interesting.
It goes hand in hand with the research too that Dr. Alexander's doing, and then we're working on some cooperation with the DoD to further that research into the user space and things like that to kind of go together as we make our enhancements. So it's great to kind of have that partnership to do that. You asked about interesting stories. There's probably nothing we can share around rootkits and things that we found. I think that it's probably not as interesting, but it was for us, which is just to see we get a chance to understand the diversity of use of Linux systems and kernels out there when people start to use this. So we started off with support for Debian, CentOS, Red Hat, Ubuntu, and Amazon Linux. And then we'll add others sort of as we go. And we've also got to understand the issues around some of them, like, Google's version of Linux and some of the issues and getting to the debug versions of it. But just seeing, how old kernels are on some people's machines that don't know the uptime of machines. And so I think there's some education we can bring to the community as well, which is keep your kernels patched for security reasons, those types of things. So for us, it wasn't really a surprise. You can kind of imagine, because we've all been in industry for a while, that people are using different flavors and maybe don't keep them up to date. That's what you would think. But the diversity has certainly been one thing that we've been not surprised at, but interesting to watch happen.
Yeah, it's really interesting to see as well just how long some of these machines run between reboots. We've seen systems that have been running for years without rebooting. And so it's kind of interesting in the sense that a lot of people will discuss secure boot technologies kind of alongside what we do, in the sense that, like, okay, secure boot technology is supposed to get you to this point where your kernel is booted up and running safely, right? But if you've been running for 3 years since that boot happened, is your kernel really at all similar to the way it booted anymore? Probably not.
Yeah. So, how does that work, with like all the live patch stuff, right? So, you can live patch kernels these days and things like that. And it's not exactly something I trust, but I guess what's your view on that?
That's a great question. Do you want me to take that one, Jason, or?
I'll start, then you can expand on it, which is, you kind of hit on live patching. So Wes and I came from, we operate at Matterport. We're serving millions of views and lots of data pulls every second, IoT as well. So the idea of live patching, where some external entity can automatically change your performance profile, is scary. That doesn't mean you need to keep your kernel out of date, though. So I understand a lot of folks don't adopt live patching, and it makes sense for those reasons. I have to understand my state of the machine I'm working in. So there's always a balance there. And so, we advocate keep your kernel up to date at a reasonable pace. Do you have to do live patching? Should you?
How does that change? How does that change the way that, like, your software is seeing the structures? Because then it's like, swapping out the legs under the table while it's floating or whatever.
Yeah, absolutely. And currently we don't support live patched systems, but we do have plans to attack those here in the somewhat near future. And the key there is the kernel maintains information about the live patches it's applying, just like it maintains information about everything else, right? So it's just a matter of us going and extracting that information. And then during the appraisal process, when we see differences, understanding that those differences are coming from the live patches, not from some sort of external entity. Right. So we've looked at that, the process by which the Linux kernels goes through and does live patching. A lot of it's based on the existing Linux kernel technologies like ftrace and stuff like that that are already out there that we need to support anyway. So we have plans there, but the current RISE product doesn't support live patch systems until we get to that work.
You say it doesn't support just because we don't know what the changes are, but a lot of those changes that come in actually don't impact what we're doing, or we've already engineered around the fact that it alters some of those things. And I think that's the IP we bring in commercializing sort of the research that was done to be able to do things like that. So, but it's hard, right? How do you verify that your thing works on something you haven't seen until the moment it shows up on a production system? But we're getting closer, that's for sure.
So you touched a little bit on IoT stuff. Your standard server distributions, I know that's like what you're targeting right now and stuff, but like IoT, bespoke kernels are kind of the standard. People are using Yocto or whatever to build their own systems like from the ground up. How do you see that fitting in with like how I guess how customers would leverage your technology with these more custom things.
Yeah. The good news is that so when Wes and I and Paul, who's also on the call, worked at Iris, we had a hub. We use Yocto and a bespoke kernel, so we have that experience. We have the ability to capture baseline. Today, we're trying to create a library baselines, especially in the server market, so you get that instant value when you appraise the system. And we can do that just by sort of how we've engineered the solution. But on a bespoke kernel, we do have the option of taking a baseline right after secure boot. And so as that hub or whatever it is runs over time, the year or 2 years that Wes was talking about, we can continue to validate its integrity. So there are ways to sort of do that. And, if it's necessary, we can get builds from customers and create a baseline even before it boots. So it just depends on the interaction with our customer and what they want to do.
Cool. Oh, let's see here. So, I mean, here in a little bit, I'm going to show a little bit of the stuff that I poked around with on it. But what types of integrations do you think that you're going to see with other people? And I guess, yeah,
how does it fit maybe in the ecosystem too? I mean, we think about that a lot. A couple of things. I talk to folks sometimes about what are we doing? We're trying to protect our customers, keep them performant, CFEngine's making sure their configuration is compliant and correct, all those things. And then you think about who's trying to affect those things and the threat actors and how are they cooperating? And so I think we need a lot more cooperation sort of on the good guy side. There is a lot today, but there's certainly a lot more that we can do. So that's, one sort of philosophy, I guess, we come to this with is how can we be of service to the rest of the ecosystem for the betterment of everybody. The second piece there is our view after running demonstrations and testing other third parties and their solutions against rootkits that we develop. It's clear to us that there's a gap there. And so if I have a security posture today that I'm trusting, our message is you might not be able to trust it if the information that's being given is incorrect. And so we provide you sort of restore trust in that stack by letting you know if your operating system's okay or not. So there's a natural integration point. And we're not out here to try to replace CFEngine or an XDR system or whatever. We don't do those other things on purpose that are being done, great by you folks. And so integration is key, and how we come together, I think, in solving these problems. I don't know, Wes, if you have.
Yeah, I mean, we talk a lot about integrations in our everyday stand-ups. It's not something that is just thought about at, the high planning level or anything like that. We talk about, who we're going to integrate with first, who we're going to do next, how's that integration going to work. We know that this piece needs to fit as seamlessly into any given customer's environment, and that in that environment, you got a couple of different kinds of customers, right? You got customers that are going to piecemeal together a security solution by buying whatever pieces they think fit best into their system, right? And so they're going to have lots of different security products already talking to each other, and we need to come into that system, be able to talk to those products as well. We also need to be able to come into a customer environment where it's like, okay, like I've bought into CrowdStrike or one of these other really large vendors, right? And we're going to need to integrate with very deeply and naturally, I think, into that environment, right? We don't want Invary to look out of place, right? We want it to fit in to your environment and look natural to you in your environment, because if it looks out of place, then that can be alarming for reasons it's not alarming over, right? We want it to be so that if we do send an alarm, you're actually alarmed because we found something real. It's very low false positive ratio with what we do. So we don't want to send kind of bad feelings with just an out of place looking integration, right? So
Right.
we know that these integrations are going to be key, and that it's important that we do them well.
What types of what type of actions, or especially automated actions? I mean, CFEngine really doesn't like to wake people up in the middle of the night. I mean, we totally can, page the sysadmin or whatever, but once you've been around the block and you kind of know like whatever the typical steps or state should look like given a specific context, CFEngine's primary idea there is to just make it the right way given the current context.
Yeah.
And so when if you've integrated with somebody and you're sending an alert, I guess, what do you think? How do you think people are going to be responding to those things? Like, especially in an automated way. Sure, we're probably going to page sysadmin for a while, but I don't know. What are your ideas around, or what do you think that you're going to see from those responses to your alert?
Right. And I also interested sort of in your guys' view because of that philosophy approach that you guys take, which is, your job is to stop these things and restore proper use without having to bother a person. I think the first thing we come from is, again, this is us bringing our operational experience to this. We don't know the domain and the context to which our software is running. So if I'm running on a Matterport server that is busy at the moment, serving lots of customers, what should I do? And so there's two actions. Can I clean it? And then the other action is, should I contain it? And so setting aside, can I clean it for a second, on the containment side, we want that to be a decision taken by the operators. But they can use CFEngine and others to say, yes, if it's on these systems, you can contain it, isolate it, shut it down, whatever you want to do. But I'm going to let them make that decision in your guys' software, essentially, and not make it for them. I think there's other products on the market. They're like, I'm just going to kernel panic. Well, if it's a critical infrastructure system, you can't do that, right? And we're not going to make that unilateral decision. On the how do I clean it off? If we do understand what it is and what it did, we do have potential to help remove it, where CFEngine could issue commands in those cases, and maybe we'll see some of that today. But that's a growing set of expertise that we're building, and rootkits are very difficult there. They on purpose sort of infest the entire kernel like a cancer. And it's difficult at times to remove them. And so we have to be very careful of what we're doing. But the good news is, if you do remove it, a second appraisal will tell you if you got it all and if your system is good again. And so that's the other value that we bring. So.
Awesome. Well, let's see here. I don't know. We could take a look. Let me move some stuff around here. Anybody else have any questions? I feel like I totally dominated.
Nick, you're doing great. I have all kinds of thoughts and questions, but I'm just appreciating the intellectual curiosity that you guys have and the practical, application of that over time. I really appreciate that.
Yeah, thanks.
Let's see here. So can you see my screen?
I can, yes.
Yeah.
All right, cool. Okay, so I've already kind of set this up a little bit here, right? So over here on the left-hand side, or at least it's my left, I don't know what it'll be mirrored on the other end. But just to speed things up, CFEngine by default runs on a 5-minute loop by default. And for demonstration purposes, that gets to be like an eternity. So I'm just running this in a pretty tight loop where it's updating its policy and then running the agent with this additional class to kind of just spit some extra information out about what Invary saw. So that's what's going on here. And then over here, I've got some toys. So I guess first thing here is this rogue rootkit, right? So I got this from the Invary guys, and it's pretty simple. It's just a little kernel module, and it can hide itself. So if I load this module, we can see that it's loaded. And then if I clear my state over here for where I had cached the data that I got from Invary, then over here, we should see this start changing because it's going to reappraise the system. So we can see, well, we could see a second ago that everything was passing. And now we've got this report URL, which I can pull up also, I think.
I was going to say you should make Craig do it in his terminals.
What's the deal here? Rise, render.
Yeah, I use all kinds of fancy tools to get by in the world, but I would prefer to not. That's okay. I'm practical.
Oh, I know what the problem is. I know what the problem is. This wraps around and it breaks the ability to like click on a link. There we go. All right, so let me pull that out of the way and pull this down. So this is the this URL here, right? It pulls up, and we can see here we have some basic information about what's going on, the different checks that Invary is doing, and that it's failing this jump tables thing and this reason here. But this report URL here, that's kind of nice and human readable. This is what we get from the Invary system. So do you guys want to tell me what I'm looking at?
Yeah, sure. So obviously we're looking at a failed appraisal here because we loaded something into the operating system that wasn't supposed to be there. In this case, like you said, we gave you a homegrown rootkit we developed based on the techniques Droga Rub and other rootkits use, but this is kind of a teaching rootkit, so it does stuff both slowly and in a benign fashion, right? So it's not actually harming your system. All we're doing here is typically just printing some stuff that'll show up in your kernel logs. And right now we've not gone through the process of like really trying to hide ourselves from the operating system, right? So we're getting a lot of information about this rogue kernel module directly. So in this case, all we've done so far is we've hijacked a couple of syscalls. In this case, the kill syscall and the get dense 64. The kill syscall we've hijacked. That's how we send commands to this particular rootkit. There's lots of ways to talk to a rootkit and send commands to it. This is one of the simpler ones. And then the get dense, we've hijacked those because it lets us hide and re-show files on disk as we want to. So in the categories here, required nodes is just there's a certain set of nodes that need to exist within any normal Linux kernel, and so we go out and we check that those nodes exist within the graph. Jump tables is a combination of things. One of the things is the syscall table, right? There's a very typical jump table, an array of function pointers. I index into the array and I jump to the function it points at, right? There's also a huge number of kind of data structures that are just operations data structures in the kernel, where it's just a set of pointers within a kernel structure, right? And so we consider those jump tables as well, do the same kind of checks on them. Are these things pointing to the function they're supposed to be pointing to? Okay. Function pointers is, there's a bunch of pointers within the kernel that aren't necessarily function pointers. But we do also know that they should be pointing to certain places within the kernel. And so we're going to check, do these function pointers point to the right places? Some of those are still, do they point to the right function in memory? Some of them are just, does this thing point to a data section that it should point to, that sort of thing. Task gates is really used on just really a lot older Linux kernels than modern kernels. Modern Linux kernels don't use task gates to do context switching anymore. So on any modern kernel, that's just going to be a success because there are no task gates. On older kernels and older systems we support, we're measuring the task gate structures that the Linux operating system uses along with the hardware to perform context switching, that sort of thing. The task tree stuff is looking at your process tree. Linux has this invariant that all running processes should descend from the init task. So we went out, measured all the running tasks, and we're looking at, I kind of mentioned before, we can look at the entire graph that came out, right? So we're looking at that entire graph and making sure that all processes we found do actually lead up through the graph to the root node, to the root process. Data nodes is a set of nodes that we expect to exist in the data section, and we expect to have very I'm trying to think of a good way to say this. They're supposed to have exact values, and we check for those exact values. So this is stuff like this particular structure, this field within that structure, that field should always be between 0 and 10, for instance, right? So we're doing checks that are kind of like that. And then the NOPS table stuff, the Linux kernel uses these NOP tables, I call them NOP slides, where essentially there's these no ops that the processors are going to execute, and it's going to slide down to an instruction below it without actually doing anything that should affect state. We want to make sure that those NOPS instructions are actually not doing anything, right? So it's not like somebody went in there and inserted instructions that start to do something instead of just sliding down to the instruction below. It's actually executing stuff as it goes down that. So that's what that's checking.
And then it looks like you pull some system information.
Yeah, so we have a bunch of insights, and we're kind of working on, what insights are going to be interesting for our customers or not. Obviously, we have this very large graph of kernel information. We can pull some interesting stuff out of that. So right now we're pulling host name and uptime and some distribution info and like details about the Linux kernel. But we're kind of investigating this and looking this as an area where we can kind of grow this part of our product and make it more interesting than it currently is.
Cool. All right, so if I move that out of the way and I slide this back down. Let's see here. I have this right here. So if I send this signal, you said you hijacked the kill.
Yep.
So if I send signal sys62 to init, I can't see this module anymore.
Yeah, so it's gone through a little bit of effort to hide itself here. Not as much as a Drovo rub level rootkit would, but it's gone through some effort here. And like I said earlier, this is a teaching rootkit, so it does these things slowly. Real rootkit would do this immediately upon being loaded, right?
Right.
So it wouldn't be something that you see as a step later.
Right. So now I cleared out my attestation report cache. And if I go to this new one, we can see here that it failed, and this is different. Saw rogue here before.
Yeah. So seeing rogue there is going to be pretty atypical of a rootkit because it is going to go through the effort of hiding itself, right? So before we were able to find information in our graph that says, oh, this address has a symbol defined. The Linux kernel maintains this k-all-sims stuff, right? And so we can go look through the k-all-sims and we can look at an address and say, okay, is there a pretty name that we can show for this particular symbol? Yes or no? In this case, because it's gone through and hidden itself, it's no longer got a pretty symbol with it, but that's the same. That is the address of the same hijacked function that we were seeing before, but now we just don't get a pretty name for it, right?
Gotcha. So let me see here. Let me pull this out of the way again. Let's come back here and look at this. So, okay, so we got the same information back into CFEngine, and then this same information in CFEngine Enterprise we can pull back, right? So I've got the same information being pulled back here into Mission Portal, so that you can kind of see what's going on. So this is the dashboard here. This is sys05 that's also running on the system. The hardening index, I don't know, we're not going to look at that, but it didn't change over this time. But I can see here that like jump tables are failing for this reason. You can pull up this compliance report that's based on the Invary attestation. Ooh, that's a mouthful. But same sort of thing here, right? I can see that the jump tables are 0 of the one host that this is being considered for are passing. And then we can see that the condition for passing is to make sure that this that this inventory place is absent, like that we didn't inventory any type of information from this jump table section of the report. And then we're only targeting these checks on places that actually have a report that's ready for us to look at. So I mean, I didn't do it in CFEngine, but like my thought was that, like, well, I've got reasons here. I probably wouldn't want to do it, unless I know what's going on, right? But if I talk to somebody and it's like, oh, this is definitely, this is Rub. We know what it looks like. This is the fingerprint from when we look at something. If you see, this information really becomes part of CFEngine's context. And so for known cases that can be enumerated, once we know that that is the context, that this is like a known rootkit, and that there is something we can do about it, we can automate that. I didn't do it in CFEngine, but right, like if I want to unhide that module,
It's so nice of the rootkit authors to have that feature.
it is. It's very. I like this manual
Like
control.
I said, learning.
But now I can see that, like, okay, the module's there, and then it, we cleaned it, however they got it in there to begin with, I don't know. But we saw it was detected. CFEngine could immediately, trigger that process to unhide the module and remove it. And maybe there's something else in the system. Well, let me do this again. Let me clear my report cache, because I would do that, after remediating that in the policy. And then another attestation will happen. We'll get a new report that will come back. Same type of thing. Let me just copy this and pull this down. Right, it's already passed, and then we'll get this information back here from CFEngine on the next run of the agent. Or we could do something to make that slow down and give us a little bit of time to get that information. The report isn't ready when CFEngine is already ready to query back the information a lot of times that I found. So that's why I ended up caching this. But now we can see that things look good, we're clean. But the way that we approach this in typical CFEngine fashion, right? We push stuff to the edge, and for CFEngine to really, CFEngine doesn't really let you push something in from the outside. There's the run agent component that will let you it'll let you request an unscheduled execution, and you can give some additional context, and you can specify some specific policies, but you can't feed something in that's just new to the system. Like, it already has to be on that other host for CFEngine to do something about it. So you just can't push in CFEngine. You can only really pull. Okay. And so, in CFEngine, the agent's running there locally. It's got elevated privileges. It can do anything on your system. And in order to make decisions about what it's doing on the system, it has to have context. And, we call that context a class, and then you can combine those multiple contexts into a class expression, using typical logic, and then, make that decision, right? This is a production system, but it's not highly critical. So therefore we can do automatic remediation for unknown problems.
Yep.
Right. Or it's a development system, and therefore we can do automatic remediation, for anything, or maybe highly critical. We can't do automatic remediation for anything. We've got to have some other signal to, to say that, well, actually a human did come and look at this, and they checked something off somewhere, on somebody's spreadsheet, and ultimately that local agent has to have all that information somehow, right? So it's this big knowledge management exercise for, how do you share that information? so that the agent can be your favorite employee who does something every 5 minutes and does the right thing because it has all the information it needs to choose to do the right thing, versus that employee that just took commands from somewhere, right? Because if I just take a command from somewhere else, that it's harder to trust that. And I mean, in this case where CFEngine's looking at the context of a system, I mean, Invary kind of becomes important for being able to trust that context of what you're seeing on the system.
Yeah.
But at any rate, we polled, all this information locally to the system, right? So we have all this information. Is this the type of do you expect that type of information to be all the way at the edge? Or do you have thoughts about like different ways of approaching this?
Yeah, lots of thought. I mean, I think that the first of all, I'd say the types of things that you're showing with CF integration is exactly what we imagined. You have a lot more. We have a context that you need to trust, but you have a lot more context to wrap around the problem as well, and your tooling to look at, deal with those things, super important, and things that we don't want to do. So I think that's great. So then you speak to how do you make these decisions? How do you share that information? For us, we do our appraisals currently on our platform for a couple of reasons. We don't want to expose any information at the machine level that we know what's going on. And so somebody could compromise, that information to know that we found them or found their techniques or whatever, right? So there's a bit of that going on. There's also, if you look at zero trust architecture, an independent entity should be attesting to the assumptions on that system. It shouldn't be the system itself saying, "Oh, I'm fine, guys, trust me." But that being said, it doesn't have to be our cloud, right? And so having it report and appraise on our appraisal code that can then sit alongside your hub in that network, also fine. And we've talked to lots of folks about how that might be necessary. Where for some folks working and speaking with our cloud who's doing the appraisal just fine, and giving that information back to their central system, sort of abstracted from their endpoints for the reasons that you described, works. And for other people, we might need to, like I said, embed that at that layer down.
I was sort of imagining that, like, at the edge, maybe a more secure way to approach that, or at least a more segmented way where you're being maybe more choosy about what you're actually sharing between things, is, we have that identifier for whatever the current report is, and that information gets reported back to the hub. And then on the hub, processes that run to get that information from the attestation platform. And then based on the information that it got for that report, the hub could then, update some other information that the agents ultimately use, like in the CMDB, and say, hey, bundle XYZ. I mean, it can be super cryptic. It doesn't have to be bundle remediate drobo or something like that. I mean, you can be as cryptic as you want and obfuscate things, but something to basically a signal that node could pick up on to say, like, I need to be doing this extra thing. There's this extra context and how it got that extra context is then like not exactly obvious.
Right.
Yeah.
Yep. And making that decision from a trusted source and not the system itself, like you're saying,
Right.
makes sense. Yep.
Interesting. Well, again, I feel like I dominated a bunch of conversation. I mean, do you guys, Craig, do you have any questions or stuff you want to share?
Like I said, I'm just really fascinated by the possibilities. There's so many different ways to go. Nick, you and I have talked about this kind of like slash and burn architecture that people seem to want to use nowadays. And this seems like a perfect opportunity for that. It's like, if you have that external view that something's gone wrong, just kill it, restart it. That makes a lot of sense to me, unfortunately.
I really don't think it makes a lot. I mean, it does in some cases or whatever, but like generally speaking, when my light bulb goes out, I don't think that the best solution is to bulldoze my house and rebuild.
But
if a minor change, like
Yeah.
going through the entire process of cutting down the forests in the Amazon, milling the boards, shipping them across the ocean, and then like that's what I feel like a lot of modern infrastructure is, and it sort of makes me sad. It's also super great in some different ways to like have that entire value chain, automated and be able to have the repeatable reproduction, but doing it for everything seems
You just made everybody using EKS or some sort of Kubernetes thing sad, by the way. I think you're right. I mean, I think a lot of it depends on the use case, right? Which is, if I'm doing a repeatable task and it's cheap to just spin up another node that's already got a cluster of 20 because that one's sick in some way, that makes sense to me, right? It's cheap, it's quick. But if I'm running a piece of critical infrastructure, or there are lots of other reasons in there that I can't just wipe myself, and there's a high cost to doing that, then we need to have capabilities to be able to change the light bulb. That's a great analogy, I think.
Yeah, and there's all kinds of other factors too, like your state, right? The data that's involved in that system. I mean, you don't want to just burn it, because you might need to know, like, what did they get, or is it corrupted now? Has it been distributed? All kinds of factors. And also I was thinking, if say CFEngine has, again, you have the knowledge management problem, right, that you're talking about, where like you're noticing patterns and you are also encapsulating some knowledge about those patterns, but in a more kind of generic way. Whereas like a virus, like the signature, like you have to put the signature into the system in order for it to know that it's there. Whereas like your technology is trying to notice things that aren't known yet. So that's pretty cool. But then like if you have like remediation, then now you do have that knowledge management problem again. I mean, it's inevitable, I think. And so then like, maybe you provide a fingerprint, of the problem, so to speak, and then maybe somebody else provides the fix for that fingerprint. And then you run into problems where like, well, what if, the rootkit knows those remediation steps? It's like, it's kind of a funny, I don't know, how to deal with that complexity. It's interesting. It's very interesting.
You hit on something that I think is important. We run into a lot, which is, our point is, today, nobody can know if these things are running on their system or not. And so let's get there first. Let's figure out that I have a problem with that out of the way. And then, what are these more difficult questions to answer around, remediation, if I don't want to rip my house down and rebuild it by burning down the Amazon. I'll never, ever flush a system and not think of that now. Burned into my brain. Yeah, for sure.
It definitely makes me think about also like your kind of bootstrapping problem, right? It was like you're analyzing and marking good a system, and you're trusting at some level that system is good, that you're fingerprinting essentially. And so, I had that problem recently with, I wanted to try out Nix OS, Nix OS. And, I ran their tool to verify their packages, and like 300 out of 5,000 packages were not verified. They were marked as not good, essentially. And I asked one of the developers, like, oh yeah, I think that's just a problem in the tool. And I'm like, okay, that's fair. But then it made me consider, well, why do I trust Debian? Why do I trust CentOS? It's like, it's a very interesting, a bootstrapping problem, right? It's like, well,
how far back do you go? Right.
Exactly. Right.
Sure.
Yeah. It's like the dependencies, and the dependencies are interesting, right? Because, well, somewhere down there, you still have to run Perl, and, it's like, there's a lot there.
When I talk to folks about, in general, cybersecurity, what you're just hitting on is a big topic, which is why, all the statistics, everybody knows them, is things aren't getting better, they're getting worse every day. And part of the reason is exactly what you're saying. Our supply chain on the software side is huge. And so, let's start at the distribution level and trust Debian. They have a lot of, great processes and things that kind of speak to that. On the flip side, though, we might not know the origin of the universe. Well, that's a deep philosophical discussion.
Yeah, sure.
But I can show you what the Big Dipper is going to be tomorrow night. And I think that in our software, while maybe, we are trusting, Debian as an institution, let's say, we're still able to say, this might be being used for some malfeasance here. The way of which that you're hiding a file seems not right. So even if that exploit, it kind of comes back into what if there's an exploit in the kernel itself, but that exploit has to manipulate to a gain, right? That gain is I'm hiding something, I'm stealing something, and that's what we catch. And so there is a layer there of like assurance that it's not just a blind trust on that side. It's about the techniques that we employ combined with that to kind of say, this isn't right. And that I was going to say it earlier too. I think that approach of a lot of existing threat detection systems would look at the night sky and go to each star and say, are you okay? Are you okay? Are you okay? And then maybe they combine 3 or 4. And it's a very difficult problem. But if you understand behavior of a system and intended invariance, team doesn't like it when I say it like that, but I think you can get to kind of where we're going. And so that's another thing in terms of cooperation. If we bring a product to market that thinks differently than the rest of the market, let's bring them together. Because we might find things that you don't, you're going to find things that we don't. We're going to wrap it up in CFEngine. You can control those policies and all those things. To me, makes a ton of sense.
Yeah, it's cool. It made me think a lot about designing software and thinking about, is there almost like a responsibility when you design and write software to somehow make it know itself?
Yeah, know thyself.
Interesting.
More Milfoil. I mean, if Dr. Alexander was here, but I don't want to speak for him. The whole field of research here is that it's really hard for developers to write secure code. That's the real problem, though, which is if we were writing better code, it would be harder. And so his research is how can you prove that it's operating with its intentions across the stack, because obviously those intentions can be violated and it's hard to create a system with no violations. So let's instead prove that an entire system is working as intended. And when it's not, then we know that something's going on. But we should all take secure coding classes every year. Ongoing CPE for engineers, for sure.
Yeah.
Awesome. Well, I don't know. Seems like I don't know. That was super fun. I had a lot of fun playing with you guys' rootkits and stuff, and hopefully I'll be able to play some more and do some more interesting stuff. I had a great conversation. It was super fun to have you guys on. So thanks for joining us.
Thank you for having us. We appreciate it. And like I said,
Great.
it's awesome to see what inside CFEngine sort of helps complete our dream, so to speak. So it's great to see what you guys put together.
That's great. I really like the fact that like it does give me a little bit of a good feeling to, like we rely on the underlying system to do our stuff. And that can be scary because, once there's a compromise, it's really hard to trust anything. And yeah, we can check for like, known context or even something that's like maybe not known, but that negative knowledge gets to be a real interesting problem in CFEngine. And yeah, having something else like that third party look down that like, the basic landscape, Pangea hasn't changed or whatever, is comforting. So anybody who's, attending live, hang around after the show if you want to ask some questions or chit chat for a bit. Otherwise, I think we can put down episode 23 in the books.
23, good number. Thanks for having us again. We appreciate it.